Hello and welcome to this first video on my new channel. So I wanted to just go over something I'm working on today because I couldn't find many resources online talking about this and thought it might be able to help someone one day out there trying to repair something. So I'm trying to repair a Hoover washing machine that has a weird fault. The screen doesn't seem to display anything anymore. Originally it was flickering and it was sometimes work, sometimes it didn't. Now it just seems to display solid digits and doesn't react at all. You can start a wash cycle, so the washing machine is obviously receiving the commands from the button presses, but it won't display anything. So I've got all of this disconnected from the washing machine at the moment and just powering the AtMega chip here on the board with 5 volts from a Raspberry Pi, and that's because I'm trying to read off the program off of the chip directly, because I suspect that there might be an issue with one of the GPIO outputs. Now I'm not 100% sure with this diagnosis, but I thought maybe when I replaced the screen, because I did try replacing this first with another model, maybe something got shorted out, maybe I damaged something, because I did read that replacing the screen should have fixed the problem. Or that does surprise me because it's a very simple circuit. There's basically nothing on it apart from a bunch of LEDs. So I thought I'll have a go at changing the chip, but before doing that I'd obviously need to back up the software on it. So that's what this video is about today. You can see if I turn the dial, nothing appears to happen. So, but the chip is definitely reading the program as the wash cycle will start. So I've connected up 6 wires here. So basically we've got the SPI interface, and then we've got ground, and we've got power. So this is connected up to a Raspberry Pi over here on the dedicated SPI pins, 5 volts and ground. So I will put up a little schematic on screen just to show the wiring, and we'll hop over to the computer so I can show you how to read the firmware. Okay, so here we are on the computer. So I've got my Raspberry Pi on the right here. It's a repurposed OctoPi that I was using before, and some instructions on the left. So obviously I've already performed all of these commands myself, but I can talk you through them. So first I downloaded the avrdude package, I extracted it, then configured it to enable Linux GPIO support. That's an important step. You build it and install it. Now this step here, you've got to go and change a configuration file. So what we want to do is do Control W and search for Linux GPIO, and there will be this section here. So originally this was commented out, so you remove the comments here and have to fill in the pins. So for the Raspberry Pi, I believe this is the same for all models. I have the Raspberry Pi 3 myself. This will be 4, 11, 10 and 9, which corresponds to GPIO for the reset, and then the pins for the SPI interface. So we can go ahead and test this now using this command. So on my washing machine board here, it's an AtMega644 chip. So you can test it here and see that it is indeed able to connect and read the device signature here, and then to copy the software off of it. I've already got a copy, but we can do for example flash free, change the name, and it will take a few seconds. So luckily for me, the lock bits were not locked, so I am able to download the firmware off of the microcontroller. Often manufacturers will lock down the chip, so you won't actually be able to read it. From what I've read, the read does succeed, but you'll just get garbage data. So you can actually inspect that using hex dump, for example, hex edit, sorry, and have a look. So you can see that the data does not repeat itself, it appears to be valid data, whereas if the lock bits were set, from what I've read, it would just be repeating bytes here with nothing to look at. So there we go, that's how you copy over the data off of a flash chip. And then to write it, all you have to do is replace here the read, the R, with a W for write. So I will try that in a next video once I've received a replacement chip. And just to show the data sheet quickly, so I have this version here of the AtMega644P. So the pins I connected to are here, these 6. So we have the SPI interface, the reset pin, VCC, which is connected to 5 volts on the Raspberry Pi, and ground. So thanks so much for watching. I will possibly have some DIY projects in the future that will be better presented than this quick explanation video. So if that's something that could interest you, don't hesitate to subscribe, and thanks so much for watching.